This is Tim and I narrating our PowerPoint presentation for you, Professor Hewitt. I'm Kevin Combs and
Tim Scruggs.
So I'm going to go first. So the project overview, Tim and I basically used aluminum from the lab and our friend's 3D printer to help print parts for our project. Some of the functions we added that we thought would be very useful are being able to adjust the front controller dock for the gun stock frame. This means that the user can slide it forward or backwards, and whatever makes it more comfortable for the user. And the detachable magnet controller holster was necessary because the user might need to reload their gun, they might need to open drawers in the game, open doors in the game. There's in a 3D games, there's lots to interact with, so it was important to be able to remove the controller and reconnect it quickly while playing the game. So the objective of this project was really distilled down to being more immersive while playing virtual reality games. And me personally, I think we succeeded at doing that. So this is the final design of our project. This picture we took was before we had the final 3D prints, so kind of set up a nice little homemade photography session, and this is the best picture we got, so that's why it's not complete, but the 3D CAD drawing, that is basically what it looks like in real life. You will see in the demo video soon. So the description of the final design, we did have 5 3D printed pieces. We used 2 pieces of aluminum. The only real issue that if we had more time we could have fixed, or if we want to on our own time we can fix, was the adjustable front controller dock. It was a little more difficult to adjust than we anticipated. It can be adjusted, but it might take 2 humans working in tandem to slide it up and down. So this is Tim playing Pavlov in a shooting range. So this video, Tim was using the shoulder stock, and you could see the importance of the magnetic holsters, which snapped away and easily reconnected easily. So you can definitely see why this is important in certain type of games. In this next demo, Tim is using it without the shoulder holster, and you do not need to remove the controllers to reload. So this is like another way to play a game, and we think it's fun.
Now I want to talk about the test results. When testing the gun stock frame, we found the final design added substantial feel and weight to the virtual gun. It really did add to the immersion. It felt like you were holding the virtual weapon. In the videos, you saw that we tested 2 different games. The first game being Pavlov, which was the manual reloading test. Although the time was increased for reloading, we still felt it was more realistic. With the gun stock frame, it was 4 seconds, and without it, it was 2. And even though the reload time was doubled, 4 seconds still felt realistic enough to us to achieve what we were trying to achieve, which was immersion. So we were okay with those results. The second game was Doom, and that was the non-manual or the automatic reloading test. And it, again, added to the immersion of the game. You felt like you were holding the actual virtual weapon. When testing the adjustable controller dock, we found the motion works to an extent. Due to the level of 3D printing for this project, excessive material was left on the surface of the 3D printed objects, so a greater force is required to move the controller dock at the moment, but with sanding, that should be fixed. The detachable controller holster motion mechanic works properly, but as you can see in the video, some practice is required for familiarization of the holster origin, but again, with practice, you should be able to get the hang of it. Multiple redesigns were required for the detachable controller holster. The first design on the far left was not able to fit on the controller at all. So once we came up with a design that was able to fit, which is the middle design, it was far too brittle for the 65-pound force required to remove from the magnetic connection. So we thickened the walls to the final design on the far right, which works properly. So in conclusion, we found that although in the design and machining phases, minor impediments were created, they weren't large enough roadblocks to really derail the assignment, and we did walk away feeling like we further developed our engineering skills. And we did see this as a learning experience. We learned how to plan around unexpected obstacles that can limit the progress of a project, kind of how to think on your feet in the moment. And it also taught us how to have multiple methods or approaches to achieve certain tasks or goals, because not the first approach isn't always going to work the first time.